Alright, now dividing rational expressions. Treat this just like multiplication. With multiplication, we multiply the two numbers underneath the radicals. Here, if it's the same radical, divide the two numbers if possible. And I can in the first one. All I do is divide 32 and negative 4 to get negative 8. So this simplifies to cube root negative 8, and I know that the cube root of negative 8 is negative 2. Okay? Over here, there's a little bit more involved, more steps, but I would do the same thing. What's 162 divided by 3?
54.
54. X to the 5th divided by x squared. What do you do to exponents when you're dividing variables? Subtract them. So 5 minus 2 is 3. Break up the 54 as 2 and 27. And I underlined the perfect cubes for you. The cube root of 27 comes out as 3. The cube root of x cubed comes out as x. And I'm left with 2 under the radical. Okay? Alright, the next example is probably the most challenging. We've talked about this before. Everybody got this down? Yeah, we've talked about rationalizing denominators before. That means you cannot have a square root in the denominator. It's easy when you have square roots. Y'all should remember this. Rationalize the denominator. Here was the original problem in blue. Square root 2 over square root 3. We cannot have a square root 3 in the denominator, so all I do is multiply the top and bottom by whatever that radical is. So on top I get root 6, bottom I get 3. Whenever you multiply a radical by itself, you get that number. Okay, so that's it for the first one. Now if I told you to rationalize square root 2 over square root 3, you should end up with square root 6 over 3. And that should be nothing new. Same thing down here. Multiply the top and bottom by the square root of 5xy. So on top I get square root 5x to the 4th y. On bottom I get 5xy. I'm going to break up. This is a perfect square right here. Agree? X to the 4th is a perfect square. Because you divide 4 by 2 to get x squared. And you're left with root 5y. And all that over 5xy. Then this x right here, divided out with one of these x's, or one of these divided out with this one, so I was left with x root 5y over 5y. Do not divide out the 5y's. Root 5y cannot divide out with plain 5y. Okay? Does that make sense? Okay, now it gets a little more complicated when you're dealing with roots other than square roots. It's easy with square roots because you just multiply the top and bottom by that square root that's in the denominator. It's not the same when you get anything other than a square root. For a cube root, in this case, see if you can figure out why I'm multiplying by cube root 9x squared. You want to be able to get rid of the radical by getting a perfect cube in the denominator. And the way I do that is with this number, 9x squared, because 9 times 3 gives me what? 27, which is a perfect cube, and x times x squared is x cubed, which is a perfect cube. So the whole thing is a perfect cube, so my next step, there will be no radical, which is what I want. So I have to multiply the top and bottom in this case by cube root 9x squared. Alright, so the top becomes cube root 18x squared. Bottom we just said becomes cube root 27x cubed, which is 3x. And I can't do anything, I can't simplify this at all, so your answer is right there.
You can't simplify 18 to 6 times 3 and then take...
Yeah, but 6 times 3, neither one of those are perfect cubes. There's no factor of 18 that's a perfect cube. Right?
I thought 6 was a perfect
Here's
cube.
my perfect cubes. 1, 8, 27, 64, 125.
So if you got 6, you couldn't say that 2 is... it's perfect.
No, 6 is not a perfect cube.